Thank you very much. Thank you all for coming. Really humbled to have this slot here right between the great business cases from Volvo Group before me, ICA, the retail chain behind me. So I hope you all stick around for those great sessions. For those of you who were here saw Fredrik's fantastic presentation from Volvo, where real data scientists, since you can see from my dress code, I am not a data scientist. I'm what we call a wannabe. Wannabes are the ones that put a lot of stickers. As you could see on Freddy's computer, he had no stickers on his laptop, so that's a real data science. So yeah, thank you very much. Glad to be here. Hope you had a really, really good beginning of the conference here. I put on like the longest title I could come up with, pretty much, to also use some good lingo and text to fit this scenario really well. We're going to talk a little bit about machine learning. I'm going to use some of the Google Big Query functionality in that and try to visualize predicted housing prices using those tools. Like I said, I'm not a statistician. How many in here are statisticians, actually, and data scientists? Usually quite a few. How many of you are using Tableau on a daily basis? Also good to know. Almost half. Interesting. So I'm a regular finance guy, so I took one class of statistics. I don't know it that well, but machine learning is really, really interesting. And I mean, one of those parts that coming into the business intelligence and analytics area really, really rapidly and big, and making us all think a little bit harder. From what we have learned and understood, if we listen to like Hollywood and all this, we know that these creatures will sooner or later do three things. They will learn everything we know and not teach them and so forth. They will most likely take all our jobs, and at the end they're probably going to kill us all. That's what Hollywood is trying to teach us. I mean, apart from maybe Wall-E then, right, who's great vacuum cleaner or something. But that's the Hollywood picture of it. When I'm looking at machine learning, and what I wanted to do is to see what can I, as a regular guy who know a little bit about intelligence, analytics, visualization, could I use some of these components without being this great statistical programmer? So I'm going to use Google BigQuery. How many in here are using Google BigQuery? Okay, I don't know if I'm going to show you anything spectacular and new. I'm going to show you a little bit about what I know about it and how I can use it and leverage it with Tableau. But looking at the Google journey around this, they're looking at it like from a data warehousing point of view. And like in the 90s, we became pretty good at storing data. And for most of you who are like a little bit younger than me, the 90s were when Sweden were really good at cross-country skiing, and I had hair. That's like how far away that was. But we started to store a lot of data. We did it really, really well. In the end of the 90s and the beginning of the 00s, we became equally good at like making use of that data with BI tools and visualizations and statistics, some reports and so forth. Dashboard came into play. And we're now at the point where we're thinking there are cheaper and smarter and better ways of storing that data, because data becomes more and more, and terabytes and petabytes and zettabytes and all of that. So there's smarter ways of storing it, and that's where Google come into play to some extent. And they're also looking at the future. What's next? What can we do with all this when we have it in place? We have it in our containers and Hadoop clusters and databases and storages. So the machine learning part is something that they introduced in beta almost a year ago now, but they're keeping it in that, and the machine learning functionality is based on all this that I think is really, really good, is that you don't have to take the data out of the container to do some statistics with it. Keep it there, apply the machine learning algorithms or regressional models and things, and see what comes out of it and see what we can do with it. Also, you don't need to learn this statistical funky language with R and Python that I think is really powerful, but I don't know it. I know a little bit of SQL, so I can write and use some of those SQL statements, and if I can use that to make a machine learning algorithm happen, that would be great, right? That's the end of my slides. So I'm going to actually go ahead and demo this a little bit. So open my Tableau, and I want to connect to Google BigQuery. It doesn't get more live than this, ladies and gentlemen. And I have some housing data here. with some price data. And looking at that, I can think, okay, what do we have? Maybe not that many records, 20, 30,000 records, and I can see when were the houses built that have been on the market here. So I'm using basic like real estate type of information from the 1890s to the 2015s or something like that. That's price. So I can see based on the price on those real estate properties. Some not very interesting. Let's look at the average price with some good coloring. And we can see, for example, there that we had some, what we here in Sweden like to call when we go out house hunting, the sekelskifte, which is really good, pricey compartments and things like that. So they're also, even in the King County, Seattle district, pretty pricey. The houses that are on the market here from the post-war era, not that pricey on an average comparable. And then some of the really, really new estates that seem to be a little bit more pricier. I can take a look at that in terms of the records by zip code. See what we have there. Some of the really popular places have more. And I could take a look at it also in terms of OpenStreetMap, like Fredrik tried, was a really good part there. So I can visualize that with color and see where the pricing in terms of average price is good or not. Swap that around to. So this is the Seattle area, and for those of you who know it well, we can see the Mercer Island, really fancy places out here, the Kirkland areas where the Bill and Melinda Gates kind of people live. So we can quite clearly see where the pricey areas statistically are located. So that's my historical data. Let me go back then into my Google BigQuery. And so now we know what we have to work with, so to speak. Always like that one. So scroll down here to my BigQuery and see what data I have in my King County housing place. So this is the one we just used, right, to take a look at statistically to see the historical parts. What I then want to use is build a query here now, where I'm going to take a look at, I can actually kick it off, it takes a little bit, but right live here for you. I'm going to create a model now from my King County housing, calling it Peter's predictions. Wonder if that will work because I already have one named that. We'll see if it fails, then I'll rerun it. And I'm telling it like what kind of regression do I want to do? I want to standard linear regression model based on price. Based on price, I want to predict the price. I want to train the model based on price, and I want to use the variables of the number of bedrooms, the number of bathrooms, the square feet living, the waterfront, and I'm not going to use zip code. Why? Because the higher the zip code, the more you will use the number of the zip codes as a variable for predicting a higher price. So that won't work. So I'm using number of bedrooms, bathrooms, square foot living, and so forth. So that's what I ran. So using the linear regression model. Let's see then if I could use that model. And I'm going to do this using my custom SQL statements. And I'm using a custom SQL statement because, is that one? Good. No. Now I have the right one. Because now I can create parameters based on those variables that I use to train my model. So I'm going to create a parameter in here for number of bedrooms, if I know how to spell right, and as an integer. From 1 to 10, I do the same with my bathrooms. Square feet. We can start on maybe 500 square feet and minimum of 100. Something like that. And then we come to the beachfront or the ocean view. Again, I could have used a Boolean here, 1 or 0, off or on, 1 or 0, so like that. There we go. So then what I built is this. Now I have predicted price instead of price. So I use, again, my OpenStreetMap using the zip codes that we had generated. I can straighten it up a little bit. Maybe coastlines and things like that to make it easier for people to see and understand what it is that I'm trying to visualize here. And then we take the predicted price. Maybe in this case I want to go red, green, and diverging, and maybe step call 10, reverse. Somewhere in the middle there, I know the prices should be good to have 750,000, something like that. Wash it out a little bit. And now I can use these parameters right off the bat. I could have created it right in here too, but it's pretty good to use it right in the custom SQL, because now I can start using these dials a little bit to look at the model that I trained and say a little bit more, what in terms of a 5 or 6 bedroom house with 3 or 4 bathrooms, 800-900 square feet, living, and now I'm looking at it based on the predicted outcomes of that model that I actually built. So 1,000-1,200 square feet. I can zoom in a little bit here and go down towards the Mercer Island or the Kirkland, Redmond area and say, what if I want a beach house right next to Bill Gates or one of those guys, and see if I turn the beach house on. Then we know exactly how the prices jump up to following the logic, but I can see how the information works with me when I'm applying it like that. Interesting view. What I also may be able to do with this, presenting it like this and applying it, is that I could let my my users who work with the web take part of that as well. So if I go down and take a look at the same model on the web for my King County housing, and looking at it from what we in Tableau call the ask data environment, to say, what if I would have an empty area and I could type in and query and ask the questions myself, looking at, okay, we have some interesting real estate data here, and say, what are the sales price by period or something like that. And it automatically looked at that and said, well, we don't have sales, but I interpret your question like price, because that's in my understanding. We don't have period or quarter, we have year built. So it interprets my query. It's like a Google query or a search engine query based on this. And I said, okay, I want to see summer price by year built. Show me the smartest way of looking at that. And then again, it should do that with me. One of those things when it's good, when it's live. So what if I take sales by region and translate it to sales by zip code? Would that be an easier way for it to interpret my question? And then again, it's represented by a map. Okay, map is interesting, good, I can see that basically what I did, but no, you know what? I actually want to see this sorted by by price in a sort. And ascending order is not exactly what I need, but maybe descending order instead. Or perhaps I can do top 10 of those or something like that. So there's one way of looking at preparing the data so that people can understand it. There's one way of using the data and use algorithms and statistics to make the data even more meaningful. And there's yet another way to present the data that has been stored and that has been manipulated and curated and presented in a smart and meaningful way. So in all essence, what I try to show here is like the way of using that within some smart and really simple and good tools, I would say, the Google and the Tableaus, and in the end, having a really smart way of visualizing it. So that's what I had prepared here for you today. Thank you.